Welcome to my thesis proposal presentation. My name is Cho Kwanchen Navio, and this is for automation, robotics and automation engineering at FIBO. And my proposal topic is a robot agent that learns group interaction through a team-based virtual reality game using effective reward reinforcement learning. Okay, here are the topics of my presentation today. First is the introduction to objectives and scope, and then we'll get into literature review, which will be divided into sections called effective gaming and reinforcement learning. Then we will get into the methodology, which consists of game design, the tools used, and the training and experimental methods. And lastly, we'll conclude with some project plans. All right, introduction. So since today, service robots are becoming more common, and these social robots are more needed to facilitate interaction with humans on a much closer, more personal scale. A little bit of background. This summer I did my internship in Japan at Kansai University at the Kansai Information Systems Laboratory, which studies these kinds of robots. So robots that can emulate emotion or detect emotion within humans. Another background topic is virtual reality systems. In recent years, advancements in graphical imaging technology and sensor technology all come together to form virtual reality systems that are more realistic than ever. So that means that experiences within virtual reality become more immersive for players and users than ever before. So they're also able to experience maybe more vivid experiences in terms of their emotions. And effective gaming was the topic of interest when I was researching for this thesis. So the field is focused on the task of helping improve players' experience in video games. So my project idea is a robot AI within a virtual reality game that can learn team cooperation according to player behavior or their psychophysiological signs. Let's move on to objectives and scope. So, 3 objectives. First, design and develop a team-based VR game. 2, implement effective gameplay through the AI using reinforcement learning. And just to clarify, the AI that will be implementing effective gameplay should be on the player's team, so as it's playing as a teammate. 3, explore team interaction between robots and human. And the scope, the project will be evaluated using a questionnaire on players on their perceptions of the robots, whether they perceive robots as parts of their team after playing, or whether they are perceived to have more human-like qualities after playing, which will differ from robots that are trained via a different objective function. And 2, the VR game will be implemented is based on a sport called round net, or you may know it as spikeball, with its official tournament rules. And number 3, the robots, as well as players' in-game bodies, shall only consist of the main torso attached to 2 floating hands, to reduce complexity of the learning problem and control problem. And number 4, the robot shall be trained using deep reinforcement learning. And number 5, the system's performance shall be further evaluated using a skin conductance sensor during runtime, and the player's performance according to these two theories. This guy, flow theory, and the Yerkes-Dodson law. So to control this experiment, the subjects will first, before playing the game, be presented with a calming environment to reduce their arousal level, and then they can play the game, and we can determine the peak arousal level that they experience during playtime. So, literature review. Within the field of effective gaming, of course, when you're thinking about emotions in science, first we have to ask the question, how do you measure how people feel? Of course, we can use sensors looking for some kind of biological sign that may indicate the level of activity of that person. So, for example, heart rate, sweat, tears. So, let's look at the model for our emotions. So this is a model presented by James Russell in 1980. It's called the circumplex model. You can see it's everywhere in psychology. So it divides emotions of a person into two distinct components that don't depend on each other. So they're called valence and arousal. So valence is how good you feel. So being pleasant or unpleasant. And arousal is the activity level or the intensity of that emotion. So on different ends of the spectrum, for example, if you're very happy and also very aroused, you might be elated, which is very happy. Or on the other end, if you're very lethargic, very low activity level, and also feel bad, you're depressed. So using that circumplex model, how do we model when a person is playing a game? What is fun? What should they feel when playing a game? Of course, the answer is fun, right? But how does that translate to the circumplex model? So these two underlying theories can sort of describe the state of a person while doing a task. So the main theory in psychology pertaining to the state of a concentration or this flow state while doing a task, it's called flow theory. So while you're doing something, if you're immersed in it and your performance is high and you're concentrated, you're focused on it, that's this guy, Csikszentmihalyi, dubbed it the flow state. And according to the task and the person's skill level, this flow state can vary. As you can see here, it's